Okay, so for this video, we're going to be talking about the difference between physical and chemical changes. So first, for a physical change to occur, thermal energy has to be involved. Either an object is losing thermal energy or it's gaining thermal energy. And that is going to change a substance in their state of matter. So, for states of matter, there's solid, liquid, and a gas. And a substance that's a gas, has the most thermal energy out of the three forms, meaning it has more collision force. So the molecules are pushing up against each other harder, so they're spreading farther apart. And that's why you can't see gases, because those molecules are spread so far apart. When heat or thermal energy is transferred to a liquid, the molecules are spreading farther apart. And so some become a gas. And those same molecules and atoms still exist, but some are just in the air now. Solids have the least amount of heat in them, so those molecules they don't have as much collision force, so they're not pushing up against each other as hard. So they're staying in position. They're just vibrating close to each other. When thermal energy is transferred to or lost by a solid, the molecules start pushing against each other harder and getting farther apart. So that's what causes the change from a solid to a liquid. Those molecules are no longer together, close, vibrating. They are spreading farther apart and kind of sliding past each other. So I did an experiment to investigate what happens when heat or thermal energy is given to a solid, and I analyzed this after I did it. So I'm going to show you solid butter versus liquid butter. Okay, that's kind of hard to see. In this hand, this is the solid butter, and this is the liquid butter. So what happened was the liquid butter was exposed to the air, which had heat in it compared to the temperature it was at before. And so it became a liquid because heat energy was given to it from the hand and from the air. So then those molecules, with that thermal energy, they started pushing each other harder and then getting farther apart. So that's what created the liquid. So I wanted to investigate that, and then after that I analyzed it to see what really happened. And you can look at that on a human scale and a molecular scale. So the human scale would just be seeing the difference between the solid butter and the liquid butter, and then a molecular scale would be looking at this chart right here. So these would be scales, and this are the molecules that are in the solid butter. They're closer together, and then when heat is added, they get farther apart, as you can see, but the mass or the weight stays the same. So whether it's a liquid or a solid, all of those atoms are still present. They're just the way that they move is different because of that heat. And the same amount of energy still exists after as it did before, because energy can't be created or destroyed. It's always going to be there. So you'll see 10 units of thermal energy in my hand, not my hand, but there's thermal energy in the hand, and that is given to the butter. So there's still 10 units of thermal energy, because heat is always transferred from the warmer substance to the colder substance. And so for cause and effect, the cause was the thermal energy being added to the butter, and the effect was the butter melting or becoming a liquid from a solid. So like I said, those molecules just spreading farther apart because it has more of that energy, so the molecules are pushing up against each other harder. So that is all you need to know in terms of a physical change in the form of the states of matter.